let's talk about how we can find the centroid of a semicircular plate. And of course, we'll be using integrals. Check this out. Here we have the equation of a semicircle, and we are going to go from negative r to r. First, we need the area of this region, which is just a semicircle, so it's just 1/2 times the area of a circle. That's pi r squared. Done. Now, we need x bar and y bar, which is just the coordinate of the centroid. But if you look at the picture, you can see that the x bar must be somewhere on the y-axis because it's symmetrical. And y bar, it must be somewhere lower here, right? Because the top right here has less area. So I will just, put it right here. X bar, y bar. But from here, we can say x bar must be equal to 0 by symmetry. And I will also show you, in case if you also like to know, what's the integral setup for the x bar. Check this out. This right here equals 1 over the area, which is 1/2 pi r squared. And we multiply by the integral going from here to here. So that's negative r to r. And then the inside, we have x times whatever this function is, which is square root of r squared minus x squared dx. Now have a look. This is an odd function, and this right here is an even function. When we multiply an odd function with an even function, the result is an odd function. And when we integrate an odd function from negative r to r, we get 0. Of course, it's the same as that. So let me just denote that right here. This is an odd function, and we get 0, of course. Now, y bar is the one that we have to do more work. And here's the setup. Y bar equals 1 over the area of the region, which is 1/2 pi r squared. And we multiply by the integral, going from negative r to r. And here we have 1/2 times whatever this function is, put that inside, and then square that. And now we just have to work this out. Firstly though, we can put the 1/2 to the front. So this right here gives us 1 over the 2 on the bottom right here times 1/2 pi r squared. And we see that the 2 and 1/2 cancel off right away. Next, the square root and the square, they cancel, which is quite nice. And you see, this right here is still an even function. So instead of going from negative r to r, we can actually just integrate it from 0 to r, but double the result. And then here we have r squared minus x squared dx. All right, let's just work this out. 2 over pi r squared. And then let's put down the result for the integration. R squared in the x world, we get r squared x. Because r is just a constant. It's just like this, integrating 4 squared dx. What do we get? Do not say the answer is 1/3, 4 to the 3rd power. No. Because 4 squared is just 16, it's just a number. You get 16x, which you can write down 4 squared x. All right, same thing. Now, this is the part that we have to use the reverse power rule. So we minus 1/3 x to the 3rd power. And then we go from 0 to r. Plugging r into all the x's, we get 2 over pi r squared. And then we have r squared times r minus 1/3 times r to the 3rd power. When we plug in 0 into here, it's 0. Plugging 0 into here is 0. Everything is 0. So it's just minus 0, which doesn't matter. Now this is r to the 3rd power, so is that. So we can get a common denominator and then just combine them. So we have 2 over pi r squared times 3 over 3 minus 1 over 3 is 2 over 3, and then r cubed. Yeah. Now we can simplify this a little bit. R squared and 2 of them cancel, so we get r to the first. For the top, we have 2 times 2 times r, so that's 4r over the bottom is 3 times pi. It's not 9, it's 3 pi. And that's it. This right here is the y-coordinate of the centroid, and then this right here is the x-coordinate of the centroid.